This video is intended primarily for my physical science classes, and we're going to look at some examples of balancing chemical reactions. Now, when we're balancing chemical reactions, our goal is to get the same number and type of element equal on both sides of the equation. So, for example, I currently have 4 chlorines on the reactant side. I only have 1 chlorine on the product side, so this reaction is not balanced as it's written. Now, the way we can balance the chemical reactions is I can add coefficients in front of each of the compounds in the chemical reaction. I can't change the subscripts, because if I do that, then I'm changing the type of compound that's present, and I can't do that when I'm balancing. All I can do is put numbers in front of each compound. But when I do, if I put a number in front of a compound, it applies to every element in that compound. Of course, the compounds are separated by the pluses. So if I put a coefficient in front of this TiCl4, it applies to the titanium and the chlorine, but not these guys. Now, there are a number of strategies for balancing chemical reactions, but I prefer the inspection method, where we sort of take each element and try to balance it systematically. It involves a little bit of trial and error, but I think this is the best method for balancing chemical reactions. So, the best way to learn how to balance chemical reactions is to practice, but I thought I'd give at least a couple examples where I can explain my thought process behind what I'm doing when I'm balancing them. So, when I start balancing a chemical reaction, I usually start and do it element by element. So when I look at this guy, I might start with titanium. And so I say, okay, I've got 1 titanium on the reactant side. I've got 1 titanium on the product side, so titanium's okay, at least for now. Then I'd move to chlorine. And so I have 4 chlorines on the reactant side. And so to get 4 chlorines on the product side, right now I've only got 1. Right? If there's no subscript, it's understood to be a 1. And so to get 4 on this side so that it equals the left, I need to put a 4 in front of the HCl. So then I would next come and do hydrogen. So right now I've got 2 hydrogens on the reactant side. I've got 4 times 1, so I've got 4 hydrogens on the product side. So in order to get 4 hydrogens on the reactant side, I need to put a 2 in front. Right? And so if I put a 2 in front of the H2O, now I'm going to have 2 times 2 is 4 hydrogens. And when I check the oxygens, I've got 2 times 1, so I've got 2 oxygens on the left, I've got 2 oxygens on the right, and so I think this equation is now balanced. But it's always good to double check, right? So I've got 1 titanium, 1 titanium, I've got 4 chlorines, I've got 4 times 1, so I've got 4 chlorines, I've got 2 times 2, so I've got 4 hydrogens, 4 times 1, I've got 4 hydrogens, 2 times 1, I've got 2 oxygens, and I've got 2 oxygens. So this equation is balanced. And let's do another example. Okay, when I look at this reaction, I see that I have nitrogen and oxygen by themselves. When that's the case, it's often easier to save those for last because I can change the coefficients on them without changing the coefficients on other elements wherein I mess them up. So let's start with hydrogen. So I have 4 hydrogens on the reactant side. I've got 2 hydrogens on the product side. So in order to balance those, I need to put a 2 in front of the water. So now I have 2 times 2, I've got 4 hydrogens on the product side. If I do oxygen next, I have 3 oxygens on the reactant side. I have to consider all the oxygens on the product side. So I've got oxygens here and here, so I've got to add them together. So I've got 2 oxygens, I've got 2 times 1, so I have a total of 4 oxygens, right? 2 from this one and 2 from this one. So whenever I see these, when I have an odd or an even number on one side and an odd number on the other, I call that an even and odd mismatch. And usually what can help balance those is to make the odd one even. And I can do that. I can make any number even by multiplying it by 2. And so that's my strategy here. So I'm going to say, all right, I'm going to put a 2 in front of this one. Now that's going to mess up the hydrogens that I'd already balanced, but that's okay. I can go back and fix those, right? So in order to fix those, let's go ahead and kill that coefficient and go back and rebalance, right? So I've got a 2 here, so I've got 2 times 4, I've got 8 hydrogens. So in order to get 8 hydrogens on this side, I need to change this coefficient to a 4. All right, and let's see what happened to the oxygens now. I've got 2 oxygens from this one. I've got 4 times 1, so 2 plus 4 is 6. So I've got 6 oxygens on the product side. I've got 2 times 3. I've got 6 oxygens on the reactant side, and so the oxygens are now balanced. And the last one we have to do is nitrogen. And so, again, I've got a nitrogen here, and they're both multiplied by 2. So I'm going to have 2 times 1 plus 2 times 1 for a total of 4 nitrogens on the reactant side. So in order to get 4 nitrogens here, I need to put a 2 in front of the N2. And so let's double check that everything's balanced. So for nitrogen, I've got 2 in the formula. So 2 times 2 is 4, and 2 times 2 is 4. I've got 2 times 4 is 8 hydrogens. 4 times 2 is 8 hydrogens. I've got 2 times 3, that's 6 oxygens. And I've got 2 oxygens plus 4 times 1, 4 oxygens from this one. So 2 plus 4 is 6. So the oxygens are also balanced. All right, let's do one more example on the next slide. All right, when I look at this chemical reaction, I see that oxygen appears all over the dang place, right? Oxygen's here and here and here. And so when that's the case, it's often easiest to save them for last. And this often happens with oxygen. Plus, the O2 is by itself, so I can change the coefficient in front of it without messing up carbons and hydrogens that are already balanced. So let's start with carbon. So I've got 1 times 3, I've got 3 carbons. I have just 1 carbon, so I think I need to put a 3 in front of the CO2. If I do the hydrogens next, I've got 8 hydrogens. I've only got 2, so I need to get this up to 8. So if I put a 4 in front, 4 times 2 is going to be 8. Now for the oxygen, I've got oxygens in 2 places on the products, just like the last problem. So I've got to add the oxygens from both compounds together. So I've got 3 times 2, so I've got 6 oxygens from this one. I've got 4 times 1, I've got 4 oxygens from that one. So add those together, that gives me 10 oxygens on the product side. So in order to get 10 oxygens on the reactant side, I need to put a 5 in front of the O2. And just to double check, I've got 3 carbons, 3 times 1, I've got 3 carbons. I've got 8 hydrogens, 4 times 2, I've got 8 hydrogens. I've got 5 times 2, 10 oxygens. I've got 3 times 2 is 6, plus 4 is 10 oxygens. So I think that's balanced as well.